Welcome back, everyone. In this video, we're going to talk about functions that have some connection to the real world. That is, functions where the input and output are connected to something physical. So, in this example, we have a couple going on a trip, and we have this function O of t, and O is a bad name, but it stands for odometer. This O of t represents the number of miles that they've put on the odometer t hours into the trip. Okay. Then we're going to ask some questions about this. But before I do that, I want to explicitly even spell out what's the input and what's the output of this function. So the input here is t, right? When I have this O of t, this t is the input. Okay. And t is the number of hours into the trip. And then the output of this function, that's this thing where it says this represents the number of miles they've put on their odometer. So this is number of miles traveled this trip, t hours in. So the way this function works is that you take an input, and that's a number of hours into the trip, and then you get an output that tells you how far they've traveled that many hours into the trip. Now, in particular, I want to point out that whenever you're dealing with functions that are connected to the real world, where you have to interpret things in that light, it really helps to pay close attention to units. And I want to point out that in this short description of what the input is and what the output is, I've already told you what the units are. Namely, the units of the input are in hours, because t here, that's the input, it's a number of hours, and the output here is a number of miles. Okay. And so you should always, as soon as you have one of these functions floating around, pay attention, what are the units of the input, and what does that input represent? What are the units of the output, and what does that output represent? Now, the first question we're asked here is, what is O of 0? And then what are the units of it? So let's first answer, what is O of 0? Well, this 0, first of all, what are the units on this 0? Well, this 0 is an input, so this 0, its units are hours. And if I read down here, this is asking about something 0 hours into the trip. Namely, what it's asking what's the total number of miles that the couple has traveled 0 hours into the trip. Well, how many miles have they traveled 0 hours into the trip? Well, in 0 time, they can have traveled a total of 0. And so O of 0, it is 0. That's the total number of miles they've traveled. But notice this 0, the output 0, it is in miles. So although that's a 0 that's an input and that's a 0 that's an output, these two zeros are very different. This is a 0 number of hours, and this is a 0 number of miles. Okay, so we're going to continue with the same function. So everywhere until I say otherwise, we're still dealing with this function O of t that we've been talking about. And so now I'm just going to tell you this additional piece of information. I'm going to tell you that O of 48 is 100. And I want to think about what the units are here and what this means. Okay. And labeling the units first is often a good way to get to what the things mean. So think for a second, is this 48 an input or an output? Okay, you should have said it's an input. Okay, and what are the inputs of this function measured in? They're measured in hours. Okay. Whereas this 100 is an output, so it's a number of miles. And so this is number of miles because it's an output. Okay. Now, I want to point out one more piece of connection between what's written here and what we said in the original problem that you might have forgotten, which is the fact that this is a 2-day trip. 2 days is 48 hours. So when we see this 48 hours, it's going to be worth it to keep in mind that this 48 hours is the same thing as 2 days. So we've got all of these things labeled here. Now let's think, what does this mean? Right, well, this function is telling me if I go some amount into the trip, so 48 hours in this case, or 2 days, how far I've traveled. And so this is 100 miles. That's telling me that that's what happened. And so literally, with no additional context, what this says is 48 hours into the trip, the couple has traveled a total of 100 miles. And so, really, if you only looked at this and the meaning of the function, you would get to this sentence. But if you take into account that also it's a 2-day trip and 48 hours is 2 days, that actually tells me not just 48 hours into the trip, the total distance they traveled was 100 miles. It tells me that the total distance they traveled over the whole trip was 100 miles. So if we add a little bit of additional information, we can get that the couple traveled 100 miles total during the trip. Next question. What does it mean if I tell you that O of 8 equals O of 16? Well, one very unhelpful way to answer this is to say, well, this is the total distance traveled in 8 hours, this is the total distance traveled in 16 hours, and so we could say the total distance traveled in 8 hours is the same as the total distance traveled in 16 hours. But I would claim that although this is accurate, it is not a very good interpretation of what this means. Namely, I think we should think one step deeper into the problem about what O of 8 equals O of 16 really is telling us, again, picturing that this is in terms of a road trip. So, we're on this road trip, and what this is saying is if I've traveled the same amount in the first 8 hours that I have in the first 16 hours, what that's really saying is we didn't go anywhere from hour 8 to hour 16. So I think a much better answer to what O of 8 equals O of 16 means is that the car was stopped from 8 hours into the trip to 16 hours into the trip. And so given that this is an 8-hour period where they didn't go anywhere, it's reasonable to speculate that perhaps they stopped at a hotel for this 8 hours for the night and then resumed driving in the morning, or whatever you like. Okay, so let's think about this one now. What does this mean? Again, I could literally translate this, and it would say the distance traveled 18 hours in is equal to the distance traveled 16 hours in plus 90. Okay, but again, this is a bad answer. This is not really giving me context about what this is really saying in terms of a road trip. Okay. And so one hint when you're faced with something like this is to ask yourself, what are the units of this 90? And so I think really, once we figure out what this 90 is, then we'll be well on our way to understanding what this statement is saying. How do I know what the units of this 90 are? Well, note I added this 90 to this O of 16. And in fact, it only makes sense to add two numbers if they have the same units, which is maybe something you haven't thought about before. But, for example, if you think about back when you talked about addition, you probably said something like, if Billy has 6 oranges and Amanda has 8 oranges, how many oranges do they have together? It doesn't really work if you say Billy has 4 cars and Amanda is 6 feet tall. what is 4 plus 6, you wouldn't really add those things together. Okay. And so specifically for addition and subtraction, if you see two numbers being added together, that means they have the same units. And so what are the units of this O of 16? Well, again, the O of 16 is the distance in miles that the car has traveled in 16 hours. So this thing is in miles. And so that means this 90 is in miles. And so what that means is that when we go to write an explanation of this, we should probably say something about what is 90 miles. Well, what is 90 miles? Well, really, if I think about the distance traveled in 16 hours and the distance traveled in 18 hours, really what I'm expressing here is what happened between hour 16 and hour 18. Namely, if in order to get the total distance traveled in hour 18, I need to add 90 miles to the number of miles traveled at hour 16, then what I'm really saying is from hour 16 to hour 18, the couple traveled exactly 90 miles. And this is a very reasonable amount of distance for the couple to have traveled during those 2 hours, because that's an average of 45 miles per hour. That works out reasonably. Okay, so let's go back to this O of 48 equals 100 example from earlier. Remember that this said that the total distance of the trip was 100 miles. And so if you believe that, then my question is, okay, how far away then is the destination from their house? And so if you think about it, if they've traveled 100 miles total, then they've traveled, this is their home, this is their destination. If they went straight there and then straight back, they'd have traveled that distance twice. Of course, very often on trips, we don't do this. We'll go something like, oh, we'll travel along here, but then we'll stop off here to get gas, and then all of these sorts of things. And so that would make the trip even longer than that. And so what that means is that this 100 is at least double the distance away. And so in particular, what does that tell us? That tells us the destination is at most 50 miles away. So, do this fact and this fact make sense together? At first, you might say, yeah, sure, they've traveled 100 miles total. Maybe they traveled 90 of those miles during this 2-hour period. Except if you keep in mind that, again, if they're going somewhere, they have to have gone there and come back. It doesn't really make sense for them to have gone there and come back in the span of 2 hours. So, in other words, when I was making this example and I thought of this question and this question, I did not really spend the time I should have to make sure that this fact and this fact actually lined up together. We're going to wrap up there for now. In the next video, we're going to talk about slopes, and how to interpret slopes in real-life functions as a rate of change. I'll see you then.